The following question states, write and balance the chemical equation for the aqueous reaction of barium hydroxide and perchloric acid to produce aqueous barium perchlorate in water. So a number of key terms. Well, first off, writing and balancing a chemical equation, they're saying our reactants are aqueous, and our what we're producing is also aqueous, and we're producing water. So let's go ahead and write this out. Well, we know barium hydroxide. We know what barium is, Ba. We know barium forms the +2 cation. We know we have hydroxide, so it should be BaOH2. Make sure you put also your identifiers, so AQ in this case, plus perchloric acid, which is HClO4, and is also aqueous. We draw a reaction arrow, and we're producing barium perchlorate, so Ba, and we know what perchlorate is, ClO4, 2, which is also aqueous, and then water. So the next thing that we have to do is this balance? Well, we have one barium. We have 2 oxygens. We have a total of 6 oxygens. Sorry, my bad. 6 oxygens plus 1 is 7. So right off the bat, we know it's not a balanced equation. Well, in order to do this, I like to balance my equations algebraically. So I always put A, B, C, and D before each of my reactants and products. And I go ahead and set A equal to 1. Once I do that, I can then start solving for different atoms on the left and right side of the arrow. I like to solve for atoms that are only present in one location on either side, and then I work my way throughout. So let's go ahead and start with barium. So we have 1 barium on the left, so 1 times A, so my coefficient, is equal to however many bariums I have on my right, which is 1. This is equal to 1C. Well, I know A is equal to 1, which is equal to 1C, so C is also equal to 1. Let's go ahead and do another one. Let's go ahead and do chlorine as well, because chlorine is located only in one location. The reason why I want to do one at a time is just makes it a lot easier so you don't have multiple systems of equations. So let's do Cl. We have 1 Cl on the right, so 1 times B. We have 2 on the right, so 2 times C. Well, we know what C is because we just solved for it. So we have 1B is equal to 2 times 1, so B is equal to 2. The last variable that we have to solve for is D, and we can solve for it in either respect to hydrogen or oxygen. I'm going to do hydrogen just because it's the first one in that in water, so let's go ahead and solve for hydrogen. Well, how many hydrogens do I have on my left side? I have 2 times A, because that's my coefficient. So I have 2 hydrogens on the left, plus 1B is equal to however many hydrogens I have on the right. 2 times D, because you're always multiplying how many you have times your coefficient. I know what A is. I know what B is. And then I can solve for the remainder. So 2 plus 2 is equal to 2D. So 4 is equal to 2D. So D is also equal to 2. This is the way that I like to solve and balance my chemical equations. I find it easiest to do so because every time you do it algebraically, you'll always get the correct response. If you prefer to do the guess and check method, that is also an accepted way. But remember, as you get to more complicated chemical equations, this tends to be the easiest and fastest way to make sure you always get the correct response. Thank you.